Hi everyone, so I hope you're doing well today. So this video is going to be about this question here, this question 5 from the 2018 Edexcel Paper 1 Pure Maths A-level exam. So it's question 5 and it's a question on differentiation. Let me just scroll down to the question again. There we go, differentiation, this question 5. So it's a question on trigonometric differentiation and it's going to involve the quotient rule. So we're going to do this today. But before we get into today's video, please do make sure you do click like and click subscribe. Click that like button, click subscribe. It really helps me out and it's free. It doesn't cost you anything and it takes you less than a second. So please do click those buttons and we'll get into today's video now. So we've got this curve here, this curve y equals 3 sine theta over 2 sine theta plus 2 cos theta with a variable theta rather than x in this case. So we want to show that dy by d theta is equal to a constant, a rational constant. So remember, a rational number is any number that can be expressed as a ratio of two integers, so it can be expressed as a fraction of two whole numbers basically. So we've got a number on the top which could be a whole number or a fraction over 1 plus sine 2 theta, where theta is between minus pi over 4 and 3 pi over 4. Okay, so it's differentiation, so it's going to be differentiating this fraction 3 sine theta over 2 sine theta plus 2 cos theta. And when you want to differentiate a fraction of two functions, so in other words, a quotient of two functions, we use the quotient rule. So in your formula book, you get the quotient rule in your formula book. So in your formula book, it looks like this. So it looks something like differentiate f of x over g of x. And then in your formula book, it says something like f dash of x times by g of x, take away g dash of x. Oh no, I'm not going to fit it in. Sorry, let me try and write a little bit smaller just so we can fit everything in. So it's g dash of x times by f of x. And then that's all divided by g of x squared. So that function squared. So that's your quotient rule formula. So your f of x function is your function on the top of your fraction. So in this case, it's 3. Well, actually, instead, we've got a variable theta. So instead of using the x, let me just get rid of that x there. And I'm going to swap it with theta because we're using a variable theta instead. So obviously, it doesn't matter what variable you use, x, theta, pi, whatever variable you like. It's the same formula. So your f of theta, your top function, is 3 sine theta. So when we differentiate 3 sine theta, obviously with respect to theta, so f dash, remember, is your derivative of your function, what you get when you differentiate your function. So if we differentiate this 3 sine theta, what do we get? Well, we get 3 cos theta. So remember that when you differentiate sine, you get cos, and that number 3 there is just a constant. It's just a multiplier. So it just multiplies your answer by 3. Okay, so our g of theta is our denominator. So in this case, it's 2 sine theta plus 2 cos theta. So when we differentiate 2 sine theta, what do we get? So we get 2 cos theta. So very similar to the first part. Sorry, let me write this down here. G dash theta. So this is the derivative of the function g of theta. So g dash of theta is what we get when we differentiate 2 sine theta plus 2 cos theta. Differentiate 2 sine theta, we get 2 cos theta. Differentiate 2 cos theta, we get minus 2 sine theta. Okay, so remember when you differentiate cos, you get minus sine. So differentiate 2 cos theta, you get minus 2 sine theta. Okay, so we've got all the information we need to plug into our formula. So we've got this, we've got that, we've got this, we've got that. So we're going to use our formula, a quotient rule formula, and just plug in our results. So we know that when we differentiate y, so this function there, so dy by d theta, we're going to get f dash. So our f dash is this thing there. So we're going to get 3 cos theta, and then times by g x, which is, well, again, we're using the variable theta, so it's g theta. So times this f dash by g theta, which is 2 sine theta plus 2 cos theta. And then we're going to have a minus sign. So there's a minus sign in our formula there. So minus sign, and then g dash theta which is this thing here. So it's 2 cos theta minus 2 sine theta. And then we're going to times that by f theta, which is this 3 sine theta. So 3 sine theta. And then we're going to divide that all by g theta squared. So this part there. So we look at our g theta, so this result there, and we're going to square it. So 2 sine theta plus 2 cos theta all squared. Okay, so we're just going to expand our brackets and simplify what we have, just to make it look a bit more tidy. So we've got here 3 times 2, which is 6. Cos theta times sine theta is sine theta cos theta. And then we've got 3 times 2 again, 6. But cos times cos is cos squared, so we get cos squared theta that. We've then got this here. We've got 2, well, a minus sign, so we're going to subtract this. So 2 times 3 again is 6. So we're going to get a minus 6, and then sine times cos is sine cos. So we're going to get a minus 6 sine theta cos theta that. And then lastly, we've got minus 2 sine theta times 3 sine theta. So we're going to get a minus 6 sine squared, but we've got this extra minus sign there. So actually we're going to add it. So a minus makes a plus. So negative 6 sine squared, which is positive 6 sine squared. So 6 sine squared that. And that's all over this on the bottom there. Now I'm actually not going to expand the brackets just yet. Let's just keep it like that for now. It's 2 sine theta plus 2 cos theta all squared. I mean, if you wanted to, you could, but let's just keep it like that for now. Now we can actually do a little bit of simplification, because look what we've got. So we've got 6 sine theta take away 6 sine theta cos theta take away 6 sine theta cos theta. So actually we just cancel that out there. So then what do we get? So we get 6 cos squared theta plus 6 sine, sorry, let me make that S look like a real S, 6 sine squared theta all over 2 sine theta plus 2 cos theta all squared. Okay, right, so hopefully if you know your trig identities, you will know that sine squared theta plus cos squared theta is 1. Now, if you look at the top here, we can actually just factorize out of 6. And what we'll get is we'll get cos squared theta plus sine squared theta. And then times obviously by the 6x, we factorize out the 6. And then we still got our denominator, which is the same as before, 2 sine theta plus 2 cos theta all squared. But obviously cos squared plus sine squared is 1, as we know from the identity. So this here, sorry, I actually do this in a different color just to make it look very clear to you guys. So this here is just equal to 1. So what we've got is 6 times 1 on the top. So we're going to get 6 times 1, which is 6. And then over this thing we had before, so 2 sine theta plus 2 cos theta all squared. So that's what we get. Now, we haven't actually answered the question, because let's go back to the question. We want to show that dy by d theta is equal to a number. So this a number could be a whole number, could be a fraction. It's a rational number over 1 plus sine 2 theta. So, I mean, obviously our denominator there is not 1 plus 2 sine theta, but we've got a number on the top, so we're getting somewhere. We're nearly there. So how are we going to get this denominator looking like a 1 plus sine 2 theta? So remember your double angle identities. So it's really important that you know your double angle identities. So remember that sine 2 theta is the same as 2 lots of sine theta cos theta. So somewhere along the line, we've got to get this like 2 sine theta cos theta somewhere appearing. So how could we do this? So I think the best way we could do this is just actually by expanding the brackets on the bottom. So if we go ahead and do that, in fact, what I'm going to do, just to actually, no, I'm not going to do that. No, let's just expand the brackets normally. So we've got 2 sine theta there plus 2 cos theta, and then times by another 2 sine theta plus 2 cos theta, because obviously we're squaring that entire thing. So then when we expand our brackets, now 2 sine theta times by 2 sine theta is a 4 sine squared theta. And then we've got a 2 cos theta times a 2 sine theta. So that's going to be a 4 sine theta cos theta. Then we've got 2 cos theta times 2 sine theta. So we get another 4 sine theta cos theta. And then lastly, we've got 2 cos theta times 2 cos theta, 4 sine squared theta. Right, okay, so let's just simplify what we've got. So we've got 6 on the top, and then we got 4 sine squared plus sorry, this is a mistake. Sorry, this is a 4 cos squared at the end. Sorry, my bad. 4 cos squared theta there. Right, okay, so we've got, I mean, if we look at the middle, we got 4 sine theta plus 4 sine theta. So we've definitely got an 8 sine theta cos theta. So 8 sine theta cos theta, because again, 4 sine theta cos theta plus another 4 sine theta cos theta is 8 lots of sine theta cos theta. And then we got this 4 sine squared theta plus this 4 cos squared theta. Okay, so again, we can do very similar to what we did before. So we've got 6 there. We can then factorize out the 4 from these first 2 terms on our denominator. So 4 sine squared plus cos squared, sorry, 4 times the sine squared plus cos squared, just by factorizing out the 4 from the first 2 terms, and then plus this 8 sine theta cos theta at the end. Now, again, hopefully you notice that sine squared plus cos squared is 1. So this down here is just equal to 1. And then also be aware of what we just said up here. So be aware, let's just go back to the top. So be aware of this result, our double angle result. So sine 2 theta is equal to 2 sine theta cos theta. Now, what happens if we times both sides of this equation by 8? Let's do this in blue, right? Sorry, by 4, sorry. Times both sides by 4. Right, so what we're going to get, obviously, the equal sign. Now, 2 times 4 is 8. So sine theta cos theta. So I'm just going to times both sides of my equation by 4, times that side by 4. So I get 8 sine theta cos theta when we times both sides of this equation by 4. So here I'm going to get 4 sine 2 theta. So 4 sine 2 theta is equal to 8 cos theta. So that's a fact. So when we go down here and see this 8 sine theta cos theta, I know that that is going to be the same as 4 sine 2 theta, because as we said up here, 8 cos sine theta, sorry, 8 sine theta cos theta is the same as 4 sine 2 theta, because we times both sides of our double angle identity by 4. So we know that that's going to be that. So what we're going to get then, again, is if we just do our fraction, so we're going to get on the top still the number 6, so we get 6 on the top, and then we got 4 times 1, that's going to be 4, and then we've got plus 4 sine 2 theta. Okay, remember the blue is 4 sine 2 theta, the red is 1, 4 times 1 is 1, sorry, 4 times 1 is 4, so we get 6 over 4 plus 4 sine theta. So now what we can do, I mean, we're nearly there. So again, if we go back to the question, we need to get a 1 sine 2 theta on the bottom, right? So we've got a 4 plus 4 sine 2 theta on the bottom. We haven't got a sorry, my page has just decided to freeze. There we go. Right, sorry for that. So we've got on the bottom of 4 plus 4 sine 2 theta. If we just factorize out of 4 on the bottom, so obviously we still got 6 there, but we can factorize out of 4. So we got 4 and then times by 1 plus sine 2 theta. Right, so we're pretty much there. Okay, so we've got on the bottom, so we got 6 over 4. Now, when you write a fraction like this, so you got 6 over 4 times this 1 plus sine 2 theta. You can actually write it like this. So you can write it like 6 over 4 over 1 plus sine 2 theta. This thing there is exactly the same as that thing there, exactly the same thing. So if you've got a number on your denominator multiplied by another number, you can bring that number to the top of your fraction like so, like I've done there. Okay, that's perfectly fine. So I'm just rub out that line. Let me get my eraser. Sorry for that. Yeah, so we've got 6 over 4, which is the same as 3 over 2, and then over 1 plus sine 2 theta. So that is our final result. That's our final answer there. So if we go back to the question, have a look. we know that we've got a over 1 plus sine 2 theta. So we've got on our bottom here 1 plus sine 2 theta, perfect. And we've got our a on the top, our rational number. 3 over 2, remember, is a rational number. So we've done the job. We've got our rational number 8. So we know that this a constant, we can just write this over here, that a is 3 over 2. So we've done it. We've answered the question, and that's our final derivative. So hopefully that will make sense. So with these questions, sometimes you just got to use a bit of trig identities to simplify our final result to get the result that they want to get in the question. So that's how we would do that question. If you are interested in having an online maths tutor for either A-level maths or GCSE maths, please do email me because I am available to help out. So my email is drdifferentiation@gmail.com. So just drop me an email, just drop me some details about you, whether you're doing A-level maths, GCSE maths, and if there's any specific areas of maths that you need help with. So drop me an email or get your parents to drop me an email, and then we can discuss everything about price, etc., etc. So drop me an email and we can get sessions booked in.